Hi folks! Today we're going to talk about completing the square, and you can see there's already some things that are written on the paper. That's because I started making a video and it froze up, and then I didn't have time to go print the other set of clean notes, so you're just going to have a little pre-filled in material here. Completing the square is kind of a cool technique. The essential question today is, how do we solve a quadratic equation by completing the square? So the purpose of completing the square is to find the solutions, which is what we've tried to do for the last several sets of notes. Your goal is still to find the solutions, the roots, the zeros, the x-intercepts. And today we're going to figure out how to do that by completing the square. So to complete the square means to take a quadratic, some kind of trinomial, and force it to be a perfect square trinomial. And hopefully a perfect square trinomial is a set of words that kind of rings a bell, because we've factored perfect square trinomials before. In fact, I'll flash my notes up there so that you can be reminded of what it looks like to factor a perfect square trinomial. Because once you force your polynomial to be a perfect square trinomial, you can easily factor it and get the solutions. So I'm going to show you my notes they're actually from last year, but they were the same that we did. So the perfect square trinomial starts out like this. You take out a GCF if you can, which we'll see a little bit of that today. The first term and the last term have to be perfect squares, and the middle term, now this is important, the middle term must be 2 times the square root of the first and the last term. 2 times the square root of the first and the last term. And once you get the square root of the first and the last term, you can put each of those pieces together and take that quantity and square it, and that's your factored format. So that's what our problems are going to kind of involve today. Our goal is to force our trinomial, no matter what it looks like, to become a perfect square trinomial so that we can get it to factor like this. So, with all that being said, let's practice what it means to complete the square. So it says that I'm going to have problems like this, and I need to fill in with a constant to complete the square. I want to take half of the b term, which remember is this right here. I'm going to take half of that, or divide it by 2, and then square this number. This completes the square. That's what will go right here as your constant. We'll have a perfect square trinomial, and then you'll be able to factor it and write it as a binomial squared. So let's practice. I'm going to take my b term, which is -8. Hang on, lost my spot. There we go. So I'm going to take my b term that's -8. I'm going to divide it by 2, and then I'm going to square that number. So -8 divided by 2 is -4, and when I square that, I get 16. So a positive 16 is what goes right here to complete the square. So then I can break this up into a binomial squared. The square root of x squared is x. The square root of 16 is 4, but I need to take that sign from the middle. It actually comes from right here, and I have -4. And that's my factored format of this perfect square trinomial. So let's try this one. Which term do I take and divide by 2? I take the b term and I divide it by 2. So here's b. I divide it by 2, and then what do I do to it? I do this, right? It says, and then square this number. Well, if I square 3 over 2, that means I square 3. So 3 squared is 9. And I square 2. 2 squared is 4. It's like distributing the squared to the numerator and the denominator. So that's my constant. That's what completes the square. So when I'm able to factor this and break it up into a binomial squared, the square root of x squared is x. The square root of 9/4 is this 3/2 that we have here. All right, let's try the last one. Last one, the b term is negative 3/4. Ooh, that'll be fun. Negative 3/4. And I don't want to divide it by 2, but I want to take half of it, which will be the same thing as dividing by 2, but when you divide a fraction by 2, that doesn't really make sense. You want to multiply it by 1/2. And then what do you do to it? You square it, right? Okay, so let's see what we have. Top times top, negative 3 times 1, that's negative 3. Bottom times bottom, 4 times 2, that's 8. And if I square it, well, that equals negative 3 squared, which is 9, and 8 squared, which is 64. So that's what completes the square, 9/64. But when I break it into its factored form, the square root of x squared is x. The square root of 9/64 is negative 3/8. There we go. So that's how I complete the square. That's the number that completes the square. And this is what I get when I factor. So let's move on and talk about how you can solve by using this completing the square method. So when you're given a polynomial, maybe you're given ax squared plus bx plus something equals something. Maybe it's not exactly in standard form, or maybe it is, but you want to move the constant. The constant, so usually like the plus c part, you want to move that to the other side of the equation by itself. That way you've kind of got this blank space that you can write in your own constant and complete the square. So whatever constant the problem came with, you want it to go over to the other side, and you want to have a space to put your own constant that completes the square. You also want to divide all terms by whatever a is. Remember, when I talk about a, I'm talking about the coefficient of the x squared term. I'm talking about this. So if a is 1, well then you're good. You don't have to do anything. But if a is something else, you want to divide all the terms by a so that you can make the coefficient of x squared 1. And it's important to have that 1 in front of x squared. That way whenever you factor, your binomial starts out with x, right? The square root of x squared is x. Then you want to complete the square. You want to do what we just learned how to do above. You're going to add this number to both sides of the equation. You want to keep your equation balanced. And then you'll be able to factor. And I'm going to save filling this in until we've actually looked at a problem, because I think if I give you all these steps now, you're going to be like, what? I don't understand this. And perhaps you're already at that point, but I think if we do an example now, it will help you out. So I'm going to move this. We're going to look at example 1. Is that in standard form, guys? Ax squared plus bx plus c equals 0 sure looks good to me. I want to move the constant to the other side of the equation by itself. What was the constant? This, right? The plus and the number with no variable. I need to move it over, which is kind of weird because in the past I've tried to move it over with everything else. But I need it out of the way. And the reason I need it out of the way is so that I have a blank space to add my new constant to have a perfect square trinomial. So I have x squared minus 10x. I'm going to have some other constant here, but then it's going to equal 0 minus 9. So negative 9. I moved that over to the other side. So I have moved my constant. I also want to divide all terms by a to make the coefficient of x squared a 1. Well, look at that. It's already a 1. So I don't have to divide by a because a is already 1. Now I want to complete the square. Remember how we did that? We took the b term, which is negative 10 here. We divided it by 2, and then we did what to it? We squared it. So negative 10 divided by 2 is negative 5. And if I square that, I get 25. That's what completes my square. But if I add 25 to the left side of my equation, I have to add it to the right side of the equation as well, because I've got to keep my equation balanced. That's something you learned in intermediate school. Keep your equation balanced. So at this point, I can take my perfect square trinomial and I can factor it. So the square root of x squared is x. The square root of 25 is negative 5. Notice how I took the sign from my completing the square work. And then what this equals is negative 9 plus 25. Well, negative 9 plus 25 is like 25 minus 9. That's 16. And the whole goal of this is to get this trinomial to a place where you can easily solve for x, get the solution. So right now I have x stuck inside of these parentheses and they're being squared. How do you undo a square? You do the opposite, you square root. And what you do to one side, you have to do to the other. So these will cancel out. I'll be left with x minus 5 equals, what's the square root of 16? Well, it's 4, but it's not just positive 4, it's also negative 4. So I have two equations here. I have x minus 5 equals 4, and I have x minus 5 equals negative 4. So this is going to give me my two solutions for my quadratic. If I add 5 to both sides, I have x equals 9. And if I add 5 to both sides here, I have x equals 1. So my solution set is 1 and 9. Okay. So in our steps, we got to this point, we factored. But then part E says, take blank. What did we take? The what? We took the square root of both sides. And we had to remember that our answers are positive and negative. And then we were able to solve for x. It's possible that you'll have a little step in there about combining like terms, but we didn't have that here. So we want to take the square root, combine like terms, and solve for x. Those were our steps. All right, so let's look at number 2. And perhaps I can fold my previous page of notes, and that way I have kind of my steps down here. There we go. All right, so step number 1. Move the constant term to one side of the equation by itself. So what's the constant term here? Constant means no variable. That'd be plus 7. If I move it over, I have to subtract 7. So we have 2x squared minus 8 minus 8x plus a blank, and that equals negative 7 with another blank. Remember, I'm going to want to balance my equation on both sides. I do need to divide all my terms by a to make sure my coefficient of x squared is 1. Well, a is 2, so I'm going to divide everything by 2. 2, 2, 2. We have x squared minus 4x. We still have a blank. And it equals negative 7 halves with a blank. Now I want to complete the square, so I'm going to take my b term. I'm going to cut it in half and square it. So negative 4 divided by 2 is negative 2. And if I square it, I get 4. So I'm going to add 4 to the left side. And I'm also going to add 4 over here so my equation is balanced. My perfect square trinomial can be factored now. So square root of x squared is x. The square root of 4 is 2, but I'm going to use negative 2 because that's what my completing the square had. And that equals negative 7 halves plus 4. Well, negative 7 halves plus 4, I need to kind of put together. So off to the side, negative 7 halves plus 8 halves. So that leaves me with 1 half. Okay. So what happens now? I want to take the square root of both sides, remember plus or minus, and then I want to solve. So if I square root the left and I square root the right, what happens to the square and the square root? They undo each other. So I have x minus 2 equals, I can't have this, so this is the square root of 1 over the square root of 2. Well, remember one of my rules is that I can't have a radical in the denominator, so I have the square root of 1, which is just 1, over the square root of 2. How do I rationalize that denominator? Multiplied by the square root of 2 on the top and on the bottom. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is just 2. So I have x minus 2 equals the square root of 2 over 2. But it's the positive and negative answer. Remember, when you square root, you get the positive and negative answer. So this gives me two different answers. It gives me one of them by x minus 2 equals square root of 2 over 2, and one of them by x minus 2 equals negative square root of 2 over 2. So, if I add 2, I get x equals 2 plus square root of 2 over 2. Same thing here. If I add 2, I get x equals 2 minus square root of 2 over 2. So I can either write that as 2 minus square root of 2 over 2, 2 plus square root of 2 over 2, or it's possible that you will see it as 2 plus or minus square root of 2 over 2. Either one is okay. All right. So let's look at example 3. Example 3 is not in standard form, nor is the constant alone moved to the other side of the equal sign. I need this negative 8 to be alone, so I'm going to just move this to the other side. So I have 3x squared. The opposite of 10x is minus 10x equals negative 8. I don't want this 3 there, so I need to do what to all the terms? I need to divide by 3. So I have x squared minus 10 thirds x with a space equals negative 8 thirds with another space. I'm going to complete the square. Negative 10 thirds needs to be cut in half. N squared. Negative 10 times 1 is negative 10. 3 times 2 is 6. And actually that can be simplified again. Negative 10 over 6 is really negative 5 over 3. So if I square that, that's 25 over 3 squared, which is 9. So that will complete my square. Plus 25 ninths. Okay. So this is all kind of what gave me this. But now I need to write my factor for my perfect square trinomial. So the square root of x squared is x. The square root of 25 ninths is negative 5 thirds. If I add these two together, I've got 25 ninths minus, let's see, times 3 times 3, 24 ninths. Well, that's easy. That's just 1/9. So when I square root both sides, the square root and the square will cancel out here. I'll have x plus 5 thirds equals plus or minus the square root of 1 over the square root of 1 is 1. The square root of 9 is 3. And now I have two equations. I have x plus 5 thirds equals 1/3, and x plus 5 thirds equals negative 1/3. I have to subtract 5 thirds from both sides. Here I get x equals 1 minus 5 thirds, so that's negative 4 thirds. And here I get x equals -1 minus 5/3. So that's -6/3 or -2. So my solutions are -2 and -4/3. Okay. So we have one more question. Oh, wait. Look at that one more time. Do you see anything? I see something. This is minus 5/3, right? What did I put here? Plus 5/3. So really, this should be minus. This should be minus. This should be minus. This should be plus. So 1 plus 5 is 6/3. 6/3 is 2. -1 plus 5 is 4. So this should be 4/3. So my answer should be 4/3 and 2, not -2 and -4/3. I'm sorry, I just noticed that. Okay. All right, so last problem, first step, move the constant over and divide by a. Pause your video, move the constant over and divide by a. Check your work. You should have a -9 on the right. You should have divided everything by 5 and left some spaces. Next step is to complete the square and put the number that completes the square on both sides of the equation. Pause your video and complete the square. When you complete the square, your b value is already a fraction, so you have to multiply it by a half. Those 2's kind of cancel out. You have the 1/5 squared, which is 1/25. Your next step is to kind of move this out of the way and bring down your factored form of your perfect square trinomial and what it equals. So fill in your next equation. Pause your video. So you should have had the square root of x squared is x, and the square root of 1/25 is 1/5. When you add these two together, you need a common denominator, so you need to multiply both the bottom and the top by 5. My work is out to the side. You end up with a sum of -44/25. Next step is to move this square by doing the opposite, which is square rooting. These will cancel out. What's left is x plus 1/5 equals, and what it equals is kind of got to be simplified over here. So we have the square root of -44 over the square root of 25. I can break this up into the square root of -1, and the square root of 4, and the square root of 11, the I, the perfect square, the leftovers, and then the square root of 25 is 5. The square root of 4 is 2. The square root of -1 is I. We have 2 I square roots of 11 over 5. So we have plus or minus 2 I square roots of 11 over 5. And then your last step is to subtract the 1/5. So if I subtract the 1/5, I want to show you a different way that you might see your answer. Instead of splitting it, you might see that x equals the -1/5 plus or minus 2I square roots of 11/5. So what this looks like together, since it has the same denominator, is -1 plus or minus 2I square roots of 11. So that's all the numerators. And then the denominator is 5. So that's what you might see as your answer. Now I know that completing the square is not the easiest thing, and there were a couple mistakes in the video which I hope actually enhanced your learning rather than hinder. But if you're confused, you do want to attend tutorials. Tutorials are going to help you go through questions that might help you become more comfortable with the steps for completing the square. So I encourage you to come to tutorials if you still have questions about completing the square.